Look at the global temperature map. While regions near the equator are running at their usual baseline, Europe is glowing like a furnace. This chart breaks down the warming rate per decade. Globally, the planet is warming at 0.2 degrees Celsius every 10 years. Asia is at 0.4, but Europe is spiking at 0.5 degrees per decade, 2.5 times the global average. The data contradicts basic geography. How is a continent positioned right next to the freezing Arctic Circle heating up faster than the tropics? The reality on the ground is extreme. In places like Madrid, street thermometers are hitting 43 degrees Celsius, nearly 110 degrees Fahrenheit. Cities built for mild, rainy weather are completely unprepared. Locals and tourists in Paris are forced to wade into public fountains beneath the Eiffel Tower just to cool off. If you want to see exactly how these planetary mechanisms work, hit the subscribe button and drop a like. We break down complex global systems with 3D analysis every week. The severe heat in Europe is a highly specific geographic trap, triggered by 3 localized environmental mechanisms interacting all at once. The first factor stems directly from Europe's geographic location. Northern Europe sits right on the doorstep of the Arctic Circle. This 3D cross-section illustrates the albedo effect. Normally, white sea ice acts like a mirror, bouncing solar radiation safely back into space. But as temperatures rise, this protective layer melts. The exposed dark ocean now absorbs the radiation, trapping heat directly in the water. We can see the scale of this retreat right now. Massive millennia-old glaciers are terminating abruptly, giving way to dark, rocky terrain and meltwater. Even out on the water, fractured sea ice breaks the reflective surface, allowing the newly exposed dark ocean patches to rapidly absorb heat. Because northern Europe lies next to this melting zone, that trapped ocean heat bleeds directly southward. Their freezing northern neighbor became an open radiator. The second mechanism involves Europe's wind. Normally, the continent's weather is moderated by cool air currents sweeping in off the Atlantic Ocean. This map shows the jet stream, a high-altitude river of wind. Historically, these currents carried mild temperatures straight across Europe, but rising temperatures are altering them. The jet stream now splits into 2 branches, one north and one south, bypassing the center completely. This split creates a high-pressure block. It sits right in the middle of those 2 branches, acting exactly like an invisible, stagnant atmospheric brick wall. That high-pressure zone repels incoming Atlantic rainstorms and locks a dome of dry, superheated air directly over the continent. The result is visible everywhere. Famous green spaces, like this park overlooking the London skyline, are baking under stagnant air, leaving the grass completely scorched. The exact wind systems that used to provide Europe with natural air conditioning are now being deflected, sealing the continent inside an atmospheric oven. The third factor driving this extreme warming is entirely man-made and highly counterintuitive. It is the direct result of Europe's successful push for cleaner air. Throughout the 20th century, heavy industry across Europe pumped vast amounts of sulfur dioxide and other pollutants straight into the sky. This cross-section shows how pollution particles, called aerosols, interact with sunlight. The dense atmospheric layer intercepted solar energy, bouncing it back into space. As strict regulations scrubbed these pollutants, the air cleared. But now, solar radiation strikes the Earth completely unobstructed, baking the ground below. By cleaning up their smog and solving a health crisis, Europe unwittingly stripped away the chemical shield that suppressed their local temperatures for decades. Because they historically never needed it, residential air conditioning is incredibly rare across the continent. Their homes, their power grids, and their daily routines simply cannot handle the tropical climate they are now experiencing. Early industrialization built these modern economies, but a century of concentrated greenhouse gas emissions has altered the physical weather systems above them. Do developing nations need to rethink their own paths to industrialization to avoid this exact geographic trap? Let us know your thoughts in the comments down below, and make sure to subscribe to the channel for more deep dives into the systems shaping our world.